Welcome back, students. This is the second part of the video of section 2.7, that is combining functions. In this video we will learn about the composition of functions. This is a very important operation that you can perform between functions, and if you are going to go in a field, in any field, whether it is applied or pure mathematics, composition of functions, they play a very important role, especially if you are in pure mathematics. As I know, they play a very important role, and this concept will stay with you forever if you are going to pursue higher studies in mathematics. Okay, so composition of functions is defined as it is very different from product. So given two functions, you can define composition of functions as given two functions f and g, the composite function. So when you operate composite functions, what you did earlier also, like the addition, subtraction, product or division, were also giving you a different function after you perform the operations. Even after you perform the composition functions, you will get back a function again, that is the composite function, that is called as composite function, and it is represented by f, a small circle, g. So this is called as composition of f and g, of f and g. So is defined by f compose g if it acts on an element. This is nothing but f of g of x. That is, you operate on the output of g. So first you operate g on x, you will get an output. So then you operate that on that output you operate f. So this is very different from product. You can see that, right? So in product you are having fg of x is nothing but f of x times g of x. So you are multiplying the different outputs and applying f and g both on x. But here in composition, it is like you apply g on x first, and then on the output apply f. So that is the composition. That means suppose if I give you a stick or a straight stick, which is like malleable, that means you can bend it to certain extent, and I will ask you to make a first bend it and then stretch it. So you will have it like you will bend the stick and then stretch the stick, correct? So if this is a function, that is bending the stick is one function, that is g, and the given stick is x. There are two processes. First you are bending it and the bent stick is being stretched. Hope you got the point. So now representing this composition of functions in terms of machine diagram and arrow diagram. So machine diagram looks, you can very well see that there are two functions. So you will be needing two machines, correct? So one machine is g machine, the other one is f machine. Okay, so what happens, you will have x entering the g machine, and you will process g of x and output g of x. Okay, and what enters the f machine is g of x. So g of x enters the f machine. So here you process f of g of x, that is you apply the function after on the ready product g of x, and then you output f of g of x. So this is the machine diagram. So if you have to draw an arrow diagram, so you have two domains or three domains. So, and this is the domain A, and this is the domain B, and this is the domain C. So now you can see that composition is possible only when the codomain, that is codomain of G, is the domain of F. Correct? B is the codomain of G and B is the domain of F. So we will see that now. This is from A, you have x here, and this function goes from A to B, and you have g of x here. So the next function would be f, that is taking g of x. So input for f is in B. So therefore domain of f is B. So g of x, and this will be f of g of x. So this is the arrow diagram. So composition cannot be done to any functions. It can be done only if the functions are of this format. That is G goes from A to B and F goes from B to C. Then f of G will go from A to C. Okay, so composition is possible only in this case, like if functions follow this particular rule. That is, domain of G should be the codomain of G should be the domain of F. So this is the codomain and this is the domain of F. And the composition will go from domain of G to codomain of F. Okay, so now we will do some problems, different kinds of problems to understand the process of composition a little better. Okay, so use f of x is equal to 2x minus, this is problem 1, 2x minus 3, and g of x is equal to 4 minus x square to evaluate f of 2. So you f of 2 is f operating twice. So you are repeatedly operating f on one particular number. Okay, so that would give us, first we will operate the ones in the brackets, f of 2. So f of 2 would be nothing but 2 times 2 wherever there is x in. Okay, I will do that in steps. Okay, f of 2 is wherever there is x, you in f of x you substitute 2 in that place. So 2 minus 3, so that is 4 minus 3, that will give us 1. Okay, so f of 2 is 1. So f of 2 is nothing but f of 1. Correct? So now wherever there is x in f function, substitute 1. So you get 2 minus 3, that is negative 1. So f of 2 is negative 1. Okay, so then the same thing we will do it for g of 3. We shall calculate g of 3 first. So g of x is 4 minus x square. So g of 3 would be wherever there is x, substitute 3. So 4 minus 3 square, that is 4 minus 9, that is equal to negative 5. Okay, so when now g of 3 would be g of negative 5, because g of 3 is negative 5. So wherever there is x, substitute -5. That would give us 4 minus of -5 the whole square. That will be 4 minus 25. That is nothing but -21. So g of 3 is -21. So this is repeated application of a particular function. This is also a composition. Let us do it for two different functions, but okay, let us do the one for the same, like in general. Let us do this, g of f of x for the same functions, where f of x is 2x minus 3 and g of x is 4 minus x square. Okay, so by definition, g composed with f is nothing but g of f of x, correct? So let us we know that f of x is 2x minus 3, so this will reduce to g of 2x minus 3. So in the place of x, you are going to substitute this whole polynomial 2x minus 3 in the function g. So that would give us 4 minus of 2x minus 3 the whole square, correct? Use the formula a minus b the whole square to expand the terms in the bracket. So that would give us 4x square minus 2 4 4 3 12, yeah, 12x plus 9. I used a minus b the whole square formula. So now operating negative sign, -1, distributing -1 within the brackets. So we will get minus 4x square plus 12x minus 9. So simplifying this further, we will get minus 4x square plus 12x minus 5. Okay, so if it is possible to factorize it, we can do it. So that is 20, correct? So 20, 5 times 4 is 20. So 20 when factorized, we get 5 fours. What are the factors? Are there any factors that gives us 12? Yeah, 5 fours are 20, 4 fives are, yeah, 20. What else? 20, 10, yeah, 210, correct? So if you factorize it, that would give us -4x plus 10x plus 2x minus 5. So this would be -2x times 2x minus 5 plus 1 times 2x minus 5. So this would reduce to 2x minus 5 times 1 minus 2x. So this is the simplified version. So make sure you express the answers in the simplified version, like the maximum simplification possible. So there is another method, like you can perform the operations of composition using table. So I will write the table of values of the functions. So composition using table. You can do it by graph also. Okay, so x, f of x, g of x. So what are all the values? 1 2 3 2 3 5 and 3 5 6 4 1 2 and 5 6 1 and 6 3 4. So these are all a table of values. That is, when x is 1, f of x produces 2 and g of x produces 3. That is what the table of values is saying us. So this is problem number 44 in the book. G composed f, calculate this. G composed f of 2. So this would be nothing but g of f of 2. So what is f of 2? That is, when x is taking the value of 2, what would be f of x? So that is in the second column. So when x is 2, f of x is 3. So g of 3. So now when x is 3, what would be the g value? That is in the third column. So when x is 3, g of x is 6. So g of 3 would be 6. So g of f of 2 is nothing but 6. So this is how you perform the composition of functions using table of values. Then we will do some more problems, because composition of functions are really important, and it is necessary you understand this very well. So composition of functions, okay, I'm sorry. Find f composed g, g composed f, f composed f, and g composed g, and their domains. Okay, this is again an exercise problem in the book. So I am considering number 52, where you are given f of x to be equal to x square and g of x to be equal to square root of x minus 3. Fine, we have to find f composed with g. This is nothing but f of g of x, correct? So what is g of x? It is square root of x minus 3. So apply f on that. That would be f of x square root of x minus 3. So that is wherever there is x in f function, you are substituting this whole polynomial there. So that is nothing but square root of x minus 3 the whole square. So squaring a square root would give us just the polynomial itself. So that is x minus 3. So what happens to g of f of x? You can see that this is not commutative, maybe or may not be in this case, but composition is not commutative, but product is commutative. Composition is not commutative. Okay, we will see that now. G of f of x. So this is equal to, what is f of x? It is x square. So substitute that in the place of f of x within the brackets. So apply g on x square. That is, we know that g is nothing but square root of x minus 3. Wherever there is x in square root of x minus 3, substitute x square. So we will get square root of x square minus 3. So this is not equal to 1 is not equal to 2. Therefore, it is not commutative. You can see that with this problem. Okay. So then we are also asked to calculate f composed f. F composed f is nothing but f of x. So that would be f of x square. So that is squaring the x square. So that would be x square whole square. That is nothing but x to the power of 4. Then g of x. I'm sorry. In the above thing, you have to have x. Okay. That is g of x. So that would give us g of square root of x minus 3. So this is wherever there is x in g function, substitute the whole thing, that is square root of x minus 3. So we will be getting square root of x minus 3 minus 3. Okay. Yeah. So we are also asked to find out the domain of each of the composed functions, right? So yeah, coming to f composed g, we got this. We got this x minus 3. So x minus 3 can take any value, right? X can take any value. So the domain would be R in this case. So coming to g composed f, we have square root. Now we have to be really careful. X square cannot be greater. When will the square root be? Square root be negative. Yeah, the value inside the square root. When will it be negative? When x square is less than 3, right? yeah, when x square is less than 3. So when does it when does x give you, x square will give you less than 3 value? When x square is 0, when x is 0 and x is 1. So anything within you are, x is not supposed to belong to closed interval 0 comma 1, correct? And also negative 1 also, right? 0 to negative 1. So x should also not belong to negative 1 to 0. So you are completely eliminating the possibility of x belonging to the interval negative 1 to 1. Okay, so what do we get the domain to be? So the domain in this case is negative infinity to negative 1 open interval union 1 to infinity. So that would be the domain. So now coming back to f composed f, there is no problem here again. So this can take any value. So domain is R. But the problem comes only when you have square root. So you have to be very careful. This term should, whole of this term should not be less. Oh, it's really difficult in this case. Okay. Yeah. The whole of the term, that is square root of x minus 3, should not be less than 3. Okay, so that means square root of x minus 3 should not be less than 3. So let us solve this inequality to find out what are all the values x can take if it has to satisfy this particular inequality. So that would be square on both the sides, x minus 3 less than 9, correct? X should be less than 9 plus 3 would be 12. So x, this particular thing is ruled out, that is x is not less than 12. So that means in the real line, anything from 12 up to negative infinity, you are totally ruling it out. Okay. Yes. So domain of g is nothing but the interval closed interval 12 to infinity. Okay, I hope you got the thing what I did now. That would be the domain. So we can also compose 3 functions. We will do such a problem now. So that is, if you are given 3 functions f, g and h, so we can do the composition. This is problem number 62. Find f composed, g composed with h. So where f of x is square root of x, g of x is x by x minus 1, h of x is cube root of x. Okay, so f composed, g composed, h of x is f of g of h of x. 1, 2. So 3 closed brackets, 3 open brackets. Yeah. Okay, good. So now first let us solve the one that is inside the brackets, h of x. So apply f of g of cube root of x is nothing but our h of x. So now apply g on cube root of x. So that will give us f of cube root of x divided by cube root of x minus 1. Now applying f for cube root of x, so that is square root of whole of the thing, that is square root of cube root of x divided by cube root of x minus 1. You can make this simpler by expressing it as a fractional power. x to the power of 3 whole to the power of 1 over 2 divided by cube root of x minus 1 whole to the power of 1 over 2. So this would give us x to the power of 3 by 2. Sorry, this is 1 over 3. Yeah, so this will be 1 over 6. So 1 over 6 divided by cube root of x minus 1 the whole to the power of 1 over 2. So this is how you compose three functions. And given a function, you can also express that as a composition form. So we will see that now. Express the function as a composition. So that would be problem number 68 in the book. H of x is equal to square root of 1 plus square root of x. See, you can see two functions here, this one and the square root, correct? So if I apply, if I take f of x to be square root of 1 plus x and g of x to be square root of x, so h of x can be treated as should we act f first or g first? Okay, so it would be f composed with g of x. So let us check whether we get the same answer if we verify it. So g of x is nothing but square root of x, right? F of square root of x is nothing but square root of 1 plus square root of x. Yes, we are getting back the capital H of x function. So you can express h of x as a composition of two functions like this. The only thing is you should identify the interlinked functions, like a function inside a function. So if you are able to identify and if you are able to judge like what has to be operated first, that would help in solving these kind of problems. So let us do another one where we have to express it as a composition of three functions. So given this is problem number 70 in the book, f of x is equal to cube root of square root of x minus 1. Okay, so yeah, so you can see this can be treated as one function and the square root of x can be treated as other function and cube root of this whole polynomial can be treated as another function. So I will write this. F of x can be written as x minus 1. G of x can be treated as square root of x and h of x can be considered to be cube root of x. Okay, so yeah, so the first operation would be f of f, correct? So f composed with the second operation would be square root of, am I right? No, I don't think so. I'm right. Okay, first operation would be g. Okay, g applied first on x will give you square root of x. Then applying square root of x on f of x will give you square root of x minus 1, right? So apply f on g and then apply h on f. So this, let us verify this. This is h of f of g of x. So that is g of x is nothing but square root of x. And f of square root of x is square root of x minus 1. And h of square root of x minus 1 would be cube root of square root of x minus 1. So we got back the given function, the original function capital F of x. So therefore we are right in expressing capital F of x as h composed with f composed with g of x. So I hope we did lots of problems, and I selected few problems from each of the exercise that you need to solve. and I have solved it, so that you will have an idea how to solve the rest of the problems, whether it is given in the quiz or homeworks. In the next video we will learn about some applications, like some applications of composition of functions. See you soon. Thanks for watching the video.